So our focus here is to think about part 3, what kind of data did we get from our activity? So just a reminder, what we're trying to figure out here is heat capacity of different substances, and we want to be able to compare the heat capacity of water to our other substances that we had, which were, of course, the isopropyl alcohol and the corn oil. So these are the 3 substances we were comparing. So when we think about what heat capacity is, it's the amount of heat that a substance can take in to get its temperature to change by that 1 degree. So it gives us an idea of how much heat and energy a substance can both absorb and release. That's why we did our 10 minutes of warming and 10 minutes of cooling, right? So our focus here, again, is to compare water to our other substances. And our goal is to essentially be able to rate each substance as a higher or a lower heat capacity compared to each other. And when we think about higher heat capacity, what that's able to do then is take in a higher heat capacity, can take in more energy, meaning it takes more time for that substance's temperature to go up. So the higher the heat capacity is, the more heat or the more energy it can take in. So a substance with a higher heat capacity will take longer to heat and cool than a substance with a lower heat capacity. Lower heat capacity, it will see a faster increase and decrease with that energy. So again, in part 1, we figured out our variables. Independent, that was what were being tested, the 3 liquids. Dependent variable is our change in temperature over time. And we had all these controls that we tried to think about. And you wrote a draft of your procedure here, what you thought you needed to do. And likely, as you were completing the lab, you're probably already thinking now, well, there's more detail that needs to be added here. So hold tight to that. That's coming up in part 4. For part 3, what we want to do is take the data we collected here and plug it into a graph. So there are, notice, 2 graphs here in part 3. They are identical. One is going to be for your adding heat data, and the second one is for the removing heat or the cooling data. So knowing you've got a graph for each one, again, they look identical, you are going to come up with a liquids key. So you'll have 3 different colors that you're using in your activity. Doesn't matter the colors to me, but you'll have 1 to represent the water, 1 to represent the corn oil, and 1 to represent the isopropyl alcohol. Oops. Oh my goodness. Isopropyl alcohol. I don't think I got it. Isopropyl alcohol. There we go. So you've got 3 colors that you're going to be using, and so that means you'll have 3 lines on your graph, 1 for each liquid. So when you set up your graph, the title is going to reflect the data that you collected, essentially if it's the warming or the cooling. The dependent variable, that goes over here on our y-axis. And so that dependent variable, remember, is our change in degrees over time. So you're going to have to look at your data table. If it spans from, let's say your data table goes from 20 degrees to 60 degrees, you want your graph to reflect that. If your data table goes from 18 to 75, you want your graph to reflect that. So you might have if this is your data you're looking at, you might start at 10 degrees and go all the way up to 70, right? Or if this is your data, you might start at 0 and go to 80. So you just got to give yourself some room and a nice even, I would just go by 5s, right? So you've got enough room to get all your data in there. And remember, Notability has this nice feature where you can go to like a light gray and a really skinny pen, and you can put in some lines on your graph. So that might help you out as you get your graph organized. So look at your overall changes in temperature, right? Change in CO2, and give yourself a scale. And you could certainly make it easy too. You could certainly go from 0 to 100. Okay, just gonna make it simplified. That's fine too. Down here, our x-axis, this is going to be our time in minutes. So we did 10 minutes on our first graph here of heating. So again, you've got that tool where you can put in your scale. You've got time 0, minute 10, and you might put in, your vertical lines so you can make that grid for yourself. And then you're going to go back and forth between your data. Remember this trick we talked about? You can look at the same document half screen, so then you can look at your data along with your graph and make it happen. So you're adding heat information, goes right onto this graph. So you would look at water, your minute number 1, or your initial, that would be your time 0. So you'd put that in, and then you'd have your minute 1 on this line, 2, 3, all the way, like we said, to minute 10. So you're going to have your water line happening on here, whatever that looks like, your corn oil line, corn oil line, and your isopropyl alcohol line. So you'll have 3 colors. And I made it really squiggly not to give you any hints, so you'll get that going. You will not be charting this final change in temperature. This will not be on the graph. Just your timed data. And you're going to repeat for down here. So again, this will be your cooling graph. You'll use your cooling data. You'll have your same liquids key, your same scales, your same lines. Okay?